Thank you very much, everyone, for attending this session. I'm Marc, Teignier, and I'm going to talk about the paper Structural Change, Land Use and Urban Expansion, which is joint work with Nicolas Cordesia and Florian Oswald. So let me start with a couple of maps to motivate the talk. They are from the town of Reims in France, but they illustrate very well the overall trend in the country. We see that here in 1866, the town of Reims is very small. It's surrounded by lots of agricultural fields. And actually, half of the workforce is in agriculture. If we check in 1950, the town is much larger, still surrounded by agricultural fields. And nowadays, almost the whole area is taken by the town of Reims. So during this period, structural change took place. Nowadays, the fraction in agriculture of the workforce is less than 1%. So there was a rise in urban population by about 3. But the rise in urban area is by a factor of 25, okay, implying this dramatic fall in average urban density of more than 8, by a factor of more than 8. So what we want to do in this paper is to propose like story related to structural change to explain this urbanization pattern that we observed in France. We also evaluate its importance quantitatively, and we examine how these interact with other explanations that are out there. Particularly, the one we're going to also try to incorporate in our model is the one we call this urban economics B, which would say that urban expansion takes place because of the fall in commuting costs, right? Which allow people to relocate from the city center to the suburbs. Our story is going to be more related about the sector reallocation. But what we think is that when workers relocate, it's also easier to relocate land. And also when consumption expenditures reallocate, the demand for housing services increase, and they all contribute to the rise in urban areas. So more specifically, our contributions will be that so first, we used historical maps together with satellite data more recently to study the evolution of urban area. And then together with census data for population, we study the evolution of urban density. Then we developed a spatial dynamic review model of structural change with endogenous land use to study this phenomenon. And we show that quantitatively, the model is able to explain the sectoral location or the sectoral reallocation, most of the fall in average urban density, the land value relocation from rural to urban, and about half of the rise in housing prices that we observe in the data in many countries, but also in France. In particular, one of the main takeaways of our paper is that agricultural productivity growth is key to explain the data. Faster commuting modes also play an important role quantitatively, but only when they are combined with agricultural productivity growth. Very briefly, in kind of the main ingredients of the model, that will be these 3 sectors. We have a rural sector, which would be the agricultural goods, an urban sector, that would be the rest of the economy, sorry, the rest of the goods, and then a housing sector that provides housing service. And land, which is in fixed supply, can be used either for agricultural production or rural food production, sorry, or for housing service. So that's going to be kind of the rival use of land. There's going to be structural change because of non-aesthetic preferences that imply a low income elasticity for the agricultural goods, and this together with productivity growth gives a structural change. And then cities emerge here because the urban good is produced at the city center. There are commuting costs, so urban workers want to locate as close as possible to the city center, and this generates this relocation of land. Right? So when workers change sectors and they go to the urban sector, they have to move to the city in this model. That will be the spatial component. And then cities can grow either vertically, so there's going to be a housing elasticity, housing price elasticity, or they could also grow kind of horizontally. And that's what the model is going to determine. Intuitively, so what would be the kind of the story, the mechanism behind the model? When agricultural productivity is very low, most of the resources are spent in the rural good. Okay? And then cities are very small because housing demand is very low, and then also very dense. as productivity growth takes place, especially in the agricultural sector, we have this reallocation of workers towards the city, which also facilitates the relocation of land. So without a big rise in prices, it's possible for cities to grow horizontally. And at the same time, as I was saying, we're going to have we're going to also incorporate this channel of a fall in commuting costs that is also going to contribute to the growth in urban areas. And then more recently, as this transition out of agriculture is almost over, we're going to have that cities don't grow much in area and value of urban land and housing prices increase faster. It's kind of what we observe in the data. So just to show you a little bit, so what we try to match the data in terms of shares, employment share and housing expenditure shares. And then the model is able also to replicate the relative price data well, and we get most of the fall in urban density. So the rise in urban population is matched pretty well, the rise in urban area not so, almost all of it, and about 75% of the fall in average urban density is captured by the model. Right? There could be other factors like zoning or other things that contribute to it. We don't have it here. So we make sure that we also match other dimensions, and we try to kind of parameterize the commuting cost function as well as possible, and we're able to replicate the evolution of commuting speed that we observe in the data for Paris, which is the only one we have. Okay, so the model also gives us this relocation of land value from rural to urban, and as I was saying, a little bit less than half of the rise in housing prices that is observed in the data. So what happens when we shut down agricultural productivity growth? So when we shut down agricultural productivity growth, what we get is that actually average urban density would rise, and it will be coming from the rise at the fringe. But it's also the case that if we don't have improvement in computing technology, we would observe a much smaller fall in urban density. Right? So it's really the combination of the two that is able to explain this. Maybe I should now stop talking and wait if there are questions.
Sorry, can I just ask one thing?
Yes.
So one thing I was wondering about, so how exactly do you match or kind of discipline the land intensity of agriculture? So normally, I suppose if there's just kind of productivity growth and this land intensity of agriculture stays kind of constant, but I suppose this is changing. This might also change over time, right?
Well, good point. I mean, here we have a constant land intensity in the agricultural production. Yeah, that's something we don't take into account. In the agricultural sector, we have labor and land, and we take the labor share as 75%, which would mean that the land share is 25%. So it's constant over time.
Okay, sorry, just to follow up on this. So because I'm wondering, so if you think of Paris, right, so then kind of the suburbs of Paris, if you're thinking of like the marginal land, that could be either land for agriculture or kind of a high rise in Paris. I feel like, you know, you could have this land anywhere else, right? And so I feel like at some point you probably have this that other land in France you would want to develop rather than kind of the suburbs of Paris for agriculture. Does that make sense?
Right. I mean, we try to document. It could be, I guess, what you have in mind is that it could be that agricultural land stays constant because Paris grows, but then they use some forest and so on. Right? Is it what you have in mind? I mean, we try to measure that. I mean, it's not possible for all countries and so on, but for all cities and so on. But we try to see, and what we find is that there is actually a relocation of land used in agriculture. This would be this plot here. It goes from about 70 to about 50. So there is a fall in the share of land allocated to agriculture by about 15 percentage points.
So Marc, I have a question too. So this is it's a very cool story. I really like it. And I had a question that maybe doesn't matter that much in the model, but maybe in the initial numbers that you showed us. So in 1865, there's not a lot of manufacturing, right? And then later you get the rise of manufacturing, and that also does take space, and it benefits from being close to the city, I guess. So when you were presenting, it sounded a bit as if the whole city, like in the 50s or now, as if it's all residential, right? In particular, when you talk about the density, but a good chunk of that might be land used for manufacturing. I guess in the model, the only thing that matters is that agriculture is more intensive in land than manufacturing, I suppose. But in terms of the data, how much of a difference does it make?
I mean, that's a good point. So in the model, exactly. So the urban good production doesn't take any land. And so yeah, the whole city is allocated to residential use. I mean, that's a good point. So how would things change if we allowed for this? That would be, so what we did, I mean, it's difficult to tell. I mean, it depends on whether you think that it's in the city center or it's in the far away. Yeah, I mean, we abstract from that. I don't have a good answer for this.
So Mark, if you want, I can quickly try. So yeah, looking at this plot, we actually measured, so this is 2016, so it's today. And we kind of can measure for each city in France, what share is used for residential stuff and what share is used from producing. And we get something about 11%, okay, in 2016. Of course, we've got no idea how that looks in historical data. And would be hard to get that data, but that's kind of the order of magnitude we have.
Thanks.
Right. And do you have any data on the price of land? That's a key mechanism. I mean, that's sort of a key centerpiece in your story, right? That's where everything connects. Do you have direct data on that?
I don't think we do, right? Sorry, I mean, it's true that it would be nice to have something like that.
Yeah, so I mean, we have it in the aggregate. So what Mark showed you before was the aggregate share of land value in GDP, but we don't have direct measures on land value. It's very hard. So we try very hard. We're almost sure in France it doesn't exist, definitely not in historical terms. We're looking at other countries. So if you have some ideas, that I think that would be useful as well. But so we need a very specific type of land value. So it needs to be geolocalized. It's hard. So we don't have it. No.
We have just under 2 minutes left. Has anyone got one last question?
If no one asked something, I would follow up on the point I made earlier. So maybe it wasn't quite clear. So what I was just wondering, so maybe I misunderstood from the model, but I understood that at the border of the city, kind of the marginal piece of land has equal value in agriculture than in housing. And I was just wondering whether you can, because this seems kind of this seems to be at least a bit in stark contrast to kind of some data moments I would have in mind, where the moment a piece of land is kind of changes the zoning restrictions, the value of that land goes up a lot. Right? So I was just wondering how we should think of this. I buy the story you have. I'm just wondering how to fit in this extra piece of information.
Right. I mean, if I understand correctly, I think it's a very good point. So in the model, it's true. The marginal land has the same value. If there were some zoning or some land regulations, this might not be the case exactly. So if we did get some data on that, maybe we could incorporate some of this zoning restrictions. Right? For the moment, we don't do that, and this could partly explain why we don't get the full rise in housing price.
Right. I mean, that would be cool if zoning would just fit in as like a buffer, right, as a wedge, and that's all, and that would be cool. That would still your story would still be totally right, and it's just zoning kind of adds a wedge. Right?
Yeah, that's a very good point.
Yeah, so we have an extension where we have this wedge. So it's a very simple extension that we can do, and it's a parameter. You turn it on, you go over the city boundary, and the price falls discretely. So we can do that. It's not in the main model because we've got no idea what that number is, of course. So it's kind of ad hoc. Oops, time's gonna run. No, it's a good suggestion. And house price is not land price, so that's also a slight difference. We can talk sometime about that.